Alright gang, today I'm going to talk about using Newton's second law to solve physics problems. Newton's second law is also known as the law of acceleration because it tells us what impacts the acceleration of an object. From the Atwood Machine Lab, you should have discovered that acceleration is directly proportional to the net force that is acting on an object. This makes a lot of sense because if you looked at the graph of your data, you should have seen that you had a linear kind of progression here. As the net force increased, the acceleration of the object increased as well. And think about it. If you push an object harder, it's going to change its motion more. The other thing that you discovered in part 2 is that the acceleration of an object is inversely proportional to the mass. This curve for this graph looked a little bit different, but it's also getting at a similar idea. As the mass increases, the acceleration of the object decreases as a result. Now this makes sense because an object with more inertia is going to be harder to change the motion of. An elephant is going to accelerate less than a mouse when you exert the same amount of force to them. These two proportionalities can be represented in equation form as follows. Sigma F is equal to ma. In this equation, sigma F is representing the net force measured in newtons, m is representing the mass measured in kilograms, and a is representing the acceleration measured in meters per second squared. Two things to keep in mind with this equation is that the net force is what you must use. Sigma F is the net force, not any individual force. So whenever you're using this equation, you must keep in mind that the net force is equal to the mass times the acceleration. The next item you must keep in mind is that the net force and the acceleration are always in the same direction. If I have a net force to the right, the object is going to accelerate to the right as a result. So let's use what we learned in order to solve this problem, which is listed here. We want to use the Guppy's method when solving this problem, but let's get a little bit of an understanding about the problem before we do that. This problem says that a 67.2 kilogram skydiver is falling and opens their parachute and slows down at a rate of 7.2 meters per second squared. We want to find what the air resistance is going to be as this skydiver falls to the ground. So first, let's get an understanding of what's going on. We have our skydiver who is plummeting to the ground and then deploys their parachute. Now in this situation, we know that the velocity of the skydiver is going to be downwards. They're falling towards the earth. Now if they deploy their parachute, they're still going to continue moving downwards, but they are going to slow down as they are falling. Because of this, we know that the acceleration must be in the upwards direction. Now if I know that the acceleration is in the upwards direction, due to Newton's second law, the net force must be in the upwards direction also. Now that I know a little bit about what's going on, let's list some of our givens. We know that there is a 67.2 kilogram skydiver. But what is that telling me? Well, the units of kilograms is telling me that that is the mass of the skydiver. I also know that they are slowing down at a rate of 7.2 meters per second squared. The 7.2 meters per second squared is letting me know the acceleration of the skydiver. I can tell from the unit also. One other thing that is given to me that isn't listed in the problem, which might be helpful, is the acceleration due to gravity, g. We know that that is going to be 9.8 meters per second squared on Earth. Now don't get confused and say that the acceleration is 9.8 meters per second squared. We know that it's not going to be 9.8 meters per second squared because the object is not in free fall. There is air resistance acting on the skydiver. Next, let's list our unknowns. The thing I want to solve in this problem is the air resistance. That is ultimately what we want to find out. Some other things that we don't know that might be useful is the weight of the skydiver and also the net force that is acting on the skydiver. Now let's check our units. I notice that the mass is in kilograms and the acceleration is in meters per second squared, which means everything is in proper units. That guy's winking. That's what that is. Now in solving these problems, the picture that we want to draw out is our free body diagram. I'm going to start by drawing a box that is representing my person. And if you want, you could write the mass in the middle of the box, the 67.2 kilograms. Now a skydiver is falling to the ground, so we know there has to be a force of gravity pulling him downwards. And we know that there is also air resistance acting on the parachute, resisting his fall. Now, before we stated that the net force has to be upwards, so they are accelerating upwards. So we know that the air resistance force has got to be greater than the weight that is acting on the skydiver. Once you have your your free body diagram, I would start off by writing down my net force equation. My net force equation for this free body diagram is going to be the force of air resistance minus the weight of the skydiver. Other equations that might be useful is Fg equals mg, as well as sigma F equals ma. Remember, we want to find the air resistance, so the net force equation is the one that we want to end up using, but if we don't know the weight and the net force, then it's going to be kind of hard to find the air resistance acting on the skydiver. So with these problems, I recommend solving for the weight of the object first. So we could say Fg is equal to mg. So I know that the weight of the skydiver is equal to 67.2 multiplied by 9.8. Doing some math, I know the weight of the skydiver is going to end up being 658.56 newtons. So that's the weight of the object. Now we could use that in order to solve the rest of the problem. Now from here, there's two ways that we could solve this problem, and I'm going to show you both ways. The first is by simply just finding the net force first. Using our net force equation, we know that the net force is equal to mass times acceleration. In other words, the net force is going to be equal to 67.2 multiplied by 7.2. Using this equation, we know that the net force is going to end up being 483.84 newtons. Now, using these two things that we just solved, we can now go back to our net force equation and solve for the air resistance. So I'm going to set up my equation once more. And I'm going to plug in the variables that I know. So we have 483.84 is equal to F air minus 658.56. In other words, when I solve for the air resistance, I'm going to get an answer of 1,142.4 newtons. Again, this makes sense because we know that the air resistance had to be greater than the weight acting on the object. Another way that we could solve this equation is by taking my two net force equations and combining them with one another. I know that net force is equal to mass times acceleration. I also know that the net force is equal to air resistance minus the force of gravity. In other words, MA is equal to F air minus Fg. With this one big equation, I could just plug in the variables that I know and solve for air resistance. In other words, I have 67.2 kilograms multiplied by 7.2 meters per second squared is equal to the force of air resistance minus the weight of the object. Solving for the air resistance, I once again get 1,142.4 newtons. So I hope this video was helpful. You could use this problem-solving method to solve all of your Newton's second law problems. Thank you. Bye-bye.